So I have a square root in this equation, which makes me tempted to want to square stuff to get rid of it. But before I do that, I'm going to want to try to isolate that square root so that when I square, that's the only thing that gets squared. So I'm going to start by subtracting x from both sides. So I get the square root of x minus 3 equals 9 minus x. And now that I've isolated the square root, now I can square both sides and it will be a productive step. Now when I square both sides, x minus 3 squared is x minus 3. And 9 minus x squared I have to calculate by foiling. I have to do 9 minus x times 9 minus x. And I get 81 minus 18x plus x squared. Now I'm just going to collect everything on one side, combine like terms, and either factor or use a quadratic formula. So I'm going to have x squared minus 19x plus 84 equals 0. This quadratic actually factors to x minus 12 times x minus 7. And if you couldn't get that, then you could easily also just use the quadratic formula, and you would come out with x equals 7 or 12. But when we plug these numbers back into the original equation, you see that only one of them is true. So let's do that on a new slide. X plus the square root of x minus 3 equals 9. And if I plug in 7 for x, I get 7 plus the square root of 4. And does that equal 9? Yes, because this says 7 plus 2, which is 9. Check. Okay, let's check our other solution. I'm going to replace the x with a 12 this time, so I get 12 plus or minus the square root of 12 minus 3, which is 9. Oops, it's just plus. Does that equal 9? So this says 12 plus 3, which is not 9. So 12 is an extraneous solution. So my only solution is x equals 7. 12 is extraneous.